Sorry. Okay, today we're gonna do homogeneous and non-homogeneous equation, undetermined equation. Ane.
So ezuzika mingi
The chapter 2,
ndimi
unit 2.
rozvipira te
Roshpira, ukuvula textbook.
famori textbook yakaniroripanganyira kana ikachikuenda iwana
Ndi einoni ine ontendera one ka WhatsApp.
ana ne asijoin
Ena kuvula ipi, ovula PDF.
no ndandidevula zveprinter out mushongo ti ndichiprinter out yabva ikuzimbiziro yopelera but then now izvinakamba ngazvo no I don't have so kumaka activity 2.2
It's alright. I could show soft copy. Shika unit 3. Sorry. Ndikoro renga textbook unne.
No.
The 100 randoms. Shika unit 3.
Unit 3. So the one zorenga textbook.
Yeah. Okay, shika unit 3 ne. Udoshimsa fumeni. PDF. Page 37.
I check.
Ukuvula. Okay. So the second order differential equation mara hapa ndo the homogeneous and non-homogeneous.
Okay.
Equation ne zvine zvaba undetermined. Ozwana.
Yeah.
Okay. So if f of x is equals to 0, if f of x equals to 0, the equation is homogeneous. So this equation is going to be what? It's going to be a homogeneous equation. And then here we have first order and second order. So this is how we're gonna see if the equation is first order or second order. It's gonna be a constant, a value. So a is a constant, dy over dx plus by equals to 0. So this is the first order equation. Okay, we call it first order. A and b are constant. A and b are constant. Okay, and then this is the first order, and then the second order is gonna be a d square y over dx squared plus b dy over dx plus cy equals to 0. So this is second order. This is a second order. Okay, and then the main reason here under homogeneous and non-homogeneous equation or undetermined equation is to calculate equation of complementary function. This is the main objective, is to find complementary function. This is the main object, which is YCF. And then the second one is to find particular integral. YPI. So under this homogeneous and non-homogeneous, we're going to be looking for YCF and YPI. So this is how we're going to determine YCF. You have to know this. To find YCF, we have to start by getting the values. Let's say we have y prime prime plus or y, or okay, plus 2y prime equals to 0. So here, what we're going to do, we're going to rewrite our equation in terms of m. So the double prime, it shows that is squared, and then the single prime, it shows that is first power. And then so we're going to have m squared because we have double prime plus 2m. So we write m when we have prime on our y's. Okay, we write m when we have prime. So here we have y prime prime, so it's going to be m squared plus 2y prime, so it's going to be 2m. So let's say we have plus maybe plus 3y equals to 0. So the 3y, because it doesn't have a prime, we were going to just write plus 3 equals to 0. This is how we're going to write it. Okay, but let's make example with this one first. So wherever there is prime, you substitute, you replace it with m. Okay, and then from here we're gonna solve for m. Okay, we can just take out m, and then we're gonna left with m plus 2 equals to 0. So here we are solving for m. Okay, so m is gonna be equals to 0 or m equals to minus 2. Okay, so in complementary function, we're gonna be looking for m. So we're gonna have m1 and m2, and so we'll be looking for m1 and m2. Okay, for complementary function. So now you have to know this equation for complementary function YCF. So let's say if m1 it's not equals to m2. Okay, let's say our m1 equals to 0, and then m2 is equals to minus 2. So the complementary function is we're gonna write it like this. It's gonna be c1 e to the power of m1x, okay, plus c2 e to the power of m2x. Okay, this is how complementary is gonna look like. Okay, so every time when you get your m's, if your m's are not equal, complementary function is gonna be like this, and then wherever there's m, you're gonna substitute with the value. So here it's gonna be c1 e to the power, our m1 is 0, so it's gonna be 0x plus c2e, m2, our m2 is minus 2, so it's gonna be minus 2x. So this is how we determine what complementary function. Okay, and then let's say when our m are equal, when our m1 equals to m2, complementary function is going to be YCF equals to c1 e to the power of m1x plus c2x e to the power of m2x. Okay, so if m1 is equals to m2, our complementary function is going to be c1 times e to the power of m1x plus c2x e to the power of m2 times x. So here we have x, and then here we don't have x. It's just c times e, and then here it's c times e, c x times e. Okay, sharp. So let's say here our m1 is equals to 1, and then also our m2 is equals to 1. So the m's are equal, and then our complementary function is gonna look like this. Sharp. And then let's say m1 let's say m1 and m2 are complex conjugate. So when we're talking about complex conjugate, it's when we have a negative square root answer. Let's say we have answer like this. We call it what? A complex. a complex conjugate. So our YCF, let's say also our M2, it's square root of -2. I'm just making an example here. So our complex conjugate YCF, complementary function, is gonna be like YCF. Let me just write it on the next page. For conjugate, okay, for let's say M1 and M2 are complex, a square root a negative square root answer. And so our YCF, it is going to be e to the power of alpha x into C1 sine beta x plus C2 cos beta x. And so this is how the complex conjugate complementary function is gonna look like. It's e to the power of alpha x C1 sine beta x plus C2 cos beta x. So this is our complementary function. The first one, it's C1 e times M1x plus C2 e to the power of M2x. And then the second one, it is going to be YCF is equals to C1 times e to the power of M1x plus C2x e to the power of M2x. And then the third one, this is the third one. YCF e to the power of alpha x into C1 sine beta x plus C2 cos beta x. Ne? Oko follower. Rochi? Hello?
Yeah, niko follower. Hello.
Okay.
That is formula ya musizi homogeneous, ne? Kona o1.
Ipio.
If f of x is equal to 0.
F of x is equal to 0. So if our f of x is equal to 0, our equation is going to be homogeneous. Ane? So we're going to have equation like this. A for constant, idoba e any value. Ane? And then a on the first order, a times dy over dx plus by is equal to 0. So this is a first order equation. When maybe let's say we are given 2y prime plus 3y equals to 0. So we call this equation what? Homogeneous.
Yeah.
Yes. And then the second order, it's a d squared y over dx squared plus b dy over dx plus cy is equals to 0. So if the equation is equals to 0, it's what? It's homogeneous. Ne? Owana. Ongara.
Yeah, and they one.
Okay. Moving forward, and then complementary function or sharp. This is our first complementary function when m is not equals to m2, when m1 is not equals to m2. And then this is our second complementary function when m1 is equals to m2. So you have to know this by head. You have to. Yeah. You have to know this.
So I read these to her from La Chitingana.
No. I read this.
Okay.
Yeah, Ojumara. Mara, I'm gonna send you notes. It's fine. Okay. Okay, remember I said our main objective here is to get what? Complementary function and a particular integral YPI. So this is how we're gonna get YCF. We check by m. If m1 is not equals to m2, this is our complementary function. If m1 is equals to m2, this is our complementary function. And m1 and m2 are complex. When we get a negative square root answer, this is our complementary function. It's e to the power of alpha x into into C1 sine beta x plus C2 cos beta x. Ne? So this is how we're gonna get CYF. And then to get YPI, so under YPI, we're going to have a linear equation. We're also gonna have a quadratic equation, exponential, trigonometric, like it's just gonna be mixed. So the particular integral YPI. So under YPI, we're going to have a linear equation, number one, a linear. So let's say your particular integral is 2x. So this is how your YPI is gonna look. You're gonna write your YPI. Your YPI, it is going to be ax plus b. Okay, your YPI, if it's linear, you know, if it's linear, it doesn't have power here. It's just to the power of 1 only. So it's linear. And then number 2, we're going to have a quadratic. So when we're talking about quadratic, it's going to be x squared. So YPI for quadratic, it is going to be YPI equals to ax squared plus bx plus c. Okay, this is for quadratic. And then number 3, we're going to also have exponential one, exponential particular integral. So when we're talking about exponential, we're going to be talking about, let's say, e to the power of negative 2x. So the YPI for exponential, it is going to be ae to the power of negative 2x. So we're going to check the exponential here. And then we just add e to the power of negative 2x. Okay, this is for what? For exponential. And then number 4, we have trigonometric. Am I too fast? Okay. Number 4, we're going to have a trigonometric. So let's say we have sine x. So the YPI for trigonometric is gonna be a cos x plus b sine x. So it can be sine x or cos x. Is the same. Our YPI is going to be the same. A cos x plus b sine x. Ne? And then sometimes they can multiply the exponential and trigonometric. So let's say we have ex and cos x. So if we have something like this, our YPI is going to be ae to the power of x cos x plus be to the power of x sine x. Okay, so this is when they multiply exponential and trigonometric. When they multiply exponential and trigonometric, this is how our YPI is gonna look like. So under YPI, we have a linear. For example, we use 2x. So YPI of a linear, it's ax plus b. Okay, and then for quadratic, x squared, we use x squared as an example. And then YPI for quadratic is ax squared plus bx plus c. And then for exponential, YPI, it's ae to the power of negative 2x. We use example, e to the power of negative 2x. Okay, and then number 4, we have a trigonometric. So we use sine or cos. So the YPI of a sine or cos is going to be a cos x plus b sine x. So sometimes they can just play around and then they multiply trigonometric and exponential. They multiply linear and trigonometric, like they just play around you. So you just know, or oh, if I have a linear, it's gonna be ax plus b, and if I have a trigonometric, it's gonna be a cos x plus b sin x. And so you just have to know, oh, okay, this is a linear, okay, this is an exponential. So now let's make an example. And then in this example, I'm also gonna show you something. Okay, so in this example, let's make an example. We're also gonna do an activity. You're gonna choose which one should we do. Okay, example, let's say we have y prime prime plus 2y prime equals to 2x plus 5. Okay, so all the y values, it's what? It's for complementary function. It's YCF. And then the x values, it's for what? It's for YPI. Okay. Yes, if you have the x value, just know it's YPI, and if you have the y values, just know it's for complementary function. Okay, so complementary function, we get them. Actually, I should not say x. The one with the prime here, the one with the to the power of this prime, or x squared plus 2yx to the power of 1. Ne? Let's say, yeah, if it's written like this, you just know, okay, this side is gonna be YCF. If it has the prime, you just know it's gonna be what? YCF. And yeah, so because sometimes they can write it as x prime plus 2x prime. So I should not say wherever this x is YPI or YCF. So wherever when you see x is YPI, no, I should just say it when you see the prime, just know that's where you're gonna get what? Your YCF. And then your YPI, remember, we have linear, quadratic, exponential, and trigonometric. And as you can see here, it's a linear. 2x plus 5, it's a linear. Okay, so what we're going to do first, we're going to start by getting YCF. We're going to get YCF. In most cases, they will ask you to determine the solution of this equation. So what you're going to do, you're just gonna write your y prime with respect in terms of m. So it's double prime, so it's gonna be m squared plus 2, so it's 1 prime, so plus m. And then you're gonna equate to 0. All the time you start like this. You check the one that has prime, and then you write it in terms of m. And then from here you solve for m. So to solve m, we're gonna take out m, and then we're gonna live with m plus 2 equals to 0. So therefore our m1 is going to be equals to 0, and m2 is going to be equals to minus 2. You're just going to solve for m. And now after here you check, oh, my m are different. If my m's are different, my complementary function, we write our complementary function like this. So it's going to be YCF equals to C1 e to the power of m1x plus C2 e to the power of m2x. So wherever there's m, I'm going to substitute with these values. So my YCF is going to be C1 e to the power of 0x plus C2 e to the power of minus 2x. So this is our YCF. This is how we determine what? YCF. And then any number to the power of 0, it's what? It's 1. So here we're going to be left with C1 plus C2 e to the power of minus 2. Do you agree? Yes. So let's write the final answer of YCF. It's going to be C1 plus C2 e to the power of minus 2x. Okay, and then now we go back. Now we're looking for YPI. We go back to our function. We started by getting YCF. This is what we used. So to get YPI, we're going to use 2x plus 5. Okay, so what we're going to write? We're going to write the 2x plus 5. And then remember to write YPI of a linear, Remember I said the YPI of a linear is equals to what? To AX plus B. It's a linear. 2x plus 5 is a linear. Okay? Did you get this part?
No.
Okay, let's go back to YPI. YPI, we said YPI, we're gonna have a linear, we can also have a quadratic, we can also have exponential. If we have a linear equation, we write our YPI as AX plus B. If we have a quadratic on our YPI side, if we have a quadratic function, we write our YPI as AX squared plus BX plus C. Okay, and then from our quotient, our YPI, it's a linear, so which means it's gonna be AX plus B. Ukozwana? Okay, so if here in our equation it was exponential, if it was exponential here, which means we were going to write our YPI as what? As, with the exponential, as AE to the power of X, if our YPI was exponential. But it's what? It's a linear. So if it's a linear, we write it as AX plus B. Okay, let's move forward. And then here under YPI, what we're going to do, we're going to check our YCF. Okay, we're going to check the highest exponent on our YCF. It's what? It's 2. So which means we're going to derivate what? 2 times. Okay, we're going to derivate 2 times. Okay, so to find YPI, we're going to check the highest exponent on the YCF side, and then we see, oh, it's second derivative, which means we're going to derive what? 2 times. We're going to derivate what? 2 times. So this is what we're going to do. It's going to be Y prime for the first time. Y prime PI equals to derivative of AX is going to be A, and then derivative of B, it's 0. Sharp. And then remember, on our side it's Y prime prime plus 2 prime. So which means here it shows that we have to derivate twice. And then we're going to derivate for the second time. It's going to be Y prime prime PI equals to the derivative of a constant is going to be 0. Okay, so now we have the Y prime prime, we also have the Y prime, we also have YPI. What we're going to do after getting the Y prime prime and YPI prime, blah 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 blah, so we're going to rewrite our equation. We're going to write our equation. Remember, our equation is Y prime prime. Oh my goodness, our equation is Y prime prime. Is it plus? Yeah, plus 2y prime equals to 2x plus 5. So, okay, plus 5. So this side, we get our y prime prime as 0 and our y prime as a. So wherever there's y prime prime, we're going to put 0, and wherever there's y prime, we're going to put a. From our original equation. So it's going to be 0 plus y prime 2 plus y prime, our y prime is a, equals to 2x plus 5, like this. Okay, and then from here we're gonna solve for a. Okay, and then as you can see here, remember our YPI, it has 2 constant, but here we only have one constant. So which means we can't solve this. Because we are looking for what? For 2 constant, for a and b. So what we're going to do here, if we can solve it further, we're gonna multiply our YPI by the smallest power of x. We're gonna multiply our YPI by the smallest value of x. So which means all the time, if we're not getting the answer. We're gonna multiply ypi by the smallest by the smallest x, by the smallest power of x. So this is how you're gonna see, or okay, I have to multiply my ypi by the smallest value, by the smallest power of x. So remember, our YCF, we get C1 plus our YCF, we got C1 plus C2 e to the power C2 times e to the power of minus 2x. So to check value, you have to multiply by x. This is how you're gonna see, okay, I have to multiply my YPI by the smallest power of x. So if on your YCF you have a constant, and also on YPI you have a constant, that's where you multiply it by what? By x. Did you get that? So all the time when you see your YCF, it has a constant or a duplicate. Like this is a constant, this is also a constant. So if we have constant in both YCF and YPI, we're gonna multiply our equation by x all the time, all the time. So let's say here on our YPI, it was a e to the power of minus 2x, which means we were also going to multiply the YPA by x because it's a duplicate. We have a constant multiplied by exponential here. They are the same. We also have a constant multiplied by exponential to the power of negative 2x. So which means also here we're going to multiply by x. If you have a repeating function from YCF and YPI, you multiply your YPI by x. Okay, ne? All the time. So you firstly, when you write your YPI, you're gonna check your YCF if it's repeating, if it's a duplicate. And so from here, remember, we're gonna check our YPI. Our YPI, it's linear. So if it's a linear, we write as ax plus b, and then we check, okay, on YCF do you have a constant? Oh yeah, even on YPI I have a constant, so I'm gonna multiply my equation by x so that we don't have a constant and a constant on both equation, so that we can also get values of a and b. If value you don't multiply, you're gonna get only one value, but we want two values. So moving forward, our YPI is gonna be ax times x. It's gonna be ax squared plus bx, like this, and then we're gonna continue we're gonna continue. Remember, our function is y prime prime plus 2y prime, which means we're going to derivate 2 times. So it's gonna be y pi prime equals to derivative of ax squared is gonna be 2ax, derivative of bx is gonna be plus b, and then and then for the second time, because we are going to derivate 2 times, ypi equals to derivative of 2ax is gonna be what? It's gonna be 2a, because derivative of b is what? It's 0. Okay, now we have the y prime prime, and then we also have the y prime. Okay, so what we're going to do, we're going to write our equation, the original one. It's equals to 2x plus 5. Okay, and then wherever there is y prime prime, we're going to substitute with what? With 2a. And then wherever there's y prime, we're going to substitute with 2ax plus b. Okay, so now we're going to have 2a plus 2 into our y prime. Y prime is 2ax plus b. Okay, so plus 2ax plus b equals to 2x plus 5. So here we just copied the original function, and then after copying the original function, we're going to substitute the values of YPI. Okay, so moving forward, we're going to solve for a and b. We're going to solve for a and b. So here, to solve for a and b, we're just going to simplify. So it's going to be 2a plus 2 times 2 is going to be 4ax plus 2b equals to 2x plus 5. And then now to solve for a and b, we're just gonna group the values together. So the one that have x, we're gonna equate it to the one with x, and then the one that doesn't have x, we're gonna equate it to 5. So what we're going to do, we're going to write 4a x equals to 2x, and then 2a plus 2b equals to 5. So here we're just grouping. We're just gonna group the one that have x together and then the one that doesn't have x together. So now from here we are looking for a is gonna be a equals to 2x divided by 4x. So we divided both sides by 4x, therefore a is going to be 1 over 2. The x and the x is going to cancel each other. 2 divided by 4, it's 1 over 2. And then from here, we can calculate b. So wherever there's a, we're going to substitute with half. So it's going to be 2 into 1 over 2 plus 2b. And then we solve for b. b, it is going to be, this is 2b. This one and this one's going to be 1, and then goes to the other side, 4. So it's going to be 5 minus 1 divided by 2, which is going to be 2. So our b is equals to 2, and our a is equals to 1 over 2. Okay, and then we're going to go back to our YPI. Our YPI is equals to what? Ax squared plus bx. So we're going to substitute the value of a and b. Our a, it was what? It was half, and then our b, it was what? It was 2. So moving forward, we're gonna write that equation of YPI, the linear one. So it's ax squared plus bx. Okay, and then our a, it's 1 over 2. It's gonna be 1 over 2x squared plus b is 2x. So this is how we determine YPI, and then at the end of the day, our y is going to be YCF plus YPI, and our YCF, it was C1 plus C2 e to the power of minus 2x, and my YPI, it's positive half x squared plus 2x. So this is how we determine this solution, the second order differential equation. You'll be given this what is it, this example, and then they say determine the solution of each of the differential equation using the method of undetermined coefficient. Method of what? Undetermined equation, a coefficient. Do you have any question here?
No,
I
don't.
Okay, so activity 3.4 cut textbook page 40. Which one should we do? We have A to G.
Are we doing one only?
We can do one, and then the other one you can practice, and then actually I'll send you the memo of this activity. Now we can do one, yes.
Okay, now let's do the first.
You can pick any from A to G.
Let's do number C.
Okay, let's do number C. Activity 3.4 number C. So it's y prime prime plus 2y prime 2y prime equals to e to the power of negative 2x. You know we are that test. Hello, confirm. Hello.
Hello.
Yeah, niko muva. Ukumfa?
Yeah, and
okay, so we're gonna do activity 3.4 number C. You know we are the test day activity.
Okay.
Yeah, so carry it, and then remember the first thing we have to get YCF. So to get YCF, we're gonna focus wherever there's prime, that's where we're gonna focus. And then so we have y prime, so it's gonna be m squared plus 2m equals to 0, and then we solve for m. And then therefore our m is going to be equals to 0, and then our other m is going to be -2. So if we have different m's, our YCF is going to be C1 e to the power of m1x plus C2 e to the power of m2x. And then we're going to substitute. Remember, m1 is 0, so any number to the power of 0 is going to be 1, so it's going to be times 1 plus C2 e to the power of -2x. And so this is how our YCF is going to look. Okay, and then now let's do YPI. Remember, our YPI, we're going to check this side. Our YPI is exponent. It's exponent. Okay, so we have e to the power of -2x. So therefore our YPI is going to be a e to the power of -2x. And then from there we're going to check, okay, on our YCF we don't have a duplicate now. Our YCF, we have C1, which is a constant, plus C2e to the power of -2x. So we have a constant multiplied by e to the power of -2x. And then our YPI, we also have a constant multiplied by e to the power of -2x. Remember, I said if we have a duplicate, we multiply our YPI by the smallest power of x. Ne? Yeah, our YCF, it's C1 plus C2 e to the power of -2x. So you can see we have a constant multiplied by e to the power of -2x. And then also when we write our YPI, it was a e to the power of -2x. So it's repeating. If it's repeating, we multiply YPI by x. Therefore our YPI is going to be ax e to the power of -2x. Anne? Yeah, and then from our original formula we had y prime plus 2y, which means we're gonna derivate our YPI 2 times. And we're gonna derivate our YPI 2 times. Okay, let's move forward. Maybe I should just write it. Okay, I'm gonna send you the notes, you'll see. So let's derivate YPI. The first derivative of YPI, it is going to be, here we have a product. It's x times, it's linear times exponential. So here we can use a product rule. Rule. What we're going to do here, remember product rule, we copy and then we derivate. We copy and then we derivate. We copy and then we derivate. So this is a constant. So we're just going to write it. Derivative of x squared. Okay, let me just start this way. We're going to start by derivative x. And then we're going to copy and then we derivate x. ae to the power of -2x. We copied, and then derivative of x, it's 1. And then we are done. Derivative x. And then plus, remember, we copy and then we derivate. We start by copying what? ae to the power of -2x, and we derivated x. And now we're going to copy what? ax, and then we derivate what? E to the power of what? E to the power of -2x. Derivative of e to the power of -x, it is going to be a -2 e to the power of -2x. So this is how we derivate e to the power of -2x. Okay, this is our first derivative. So it's ae to the power of negative 2x times 1 plus negative 2. Remember here we have a negative. Oh, sorry. Minus 2ax e to the power of negative 2x. Uko first hapa noni? Yeah, we started by copying ae and then we derivated x. And then we copied ax and then we derivated e to the power of negative 2x. Remember our equation is y prime prime, which means we're going to derivate for the second time. Okay, so it's going to be y prime prime pi equals to. So we're going to focus here to derivate for the second time. And so to derivate for the second time, remember we copy and then we derivate. We copy and then we derivate. And so here we have a constant and e to the power of negative 2x. So we're going to copy a and then we derivate e to the power of negative 2x. Derivative of e to the power of negative 2x is what? It's going to be a negative 2 e to the power of negative 2x minus, okay, we are done derivating a e to the power of negative 2x. So derivative of a e to the power of negative 2x is going to be a multiplied by negative 2e to the power of negative 2x minus, and then now we're going to focus here. Let's use a different color. So now we're going to focus on 2ax e to the power of negative 2x. Okay, so that's where we're going to focus. Remember here is a product. We have a linear and exponential. We copy, we derivate, we copy, and then we derivate. Ne? So we are going to start by copying 2a and then e to the power of negative 2x, and then we derivate x. So it's going to be 2a e to the power of negative 2x and the derivative of x, which is 1, plus we're going to copy 2ax, and then we derivate what? E to the power of negative 2. Derivative of e to the power of 2 is going to be negative 2 e to the power of negative 2x. Uko first, yeah, and then we're going to simplify. Okay, our y prime prime, it is going to be negative 2ae to the power of negative 2x. So it's going to be negative 2ae to the power of negative 2x, and then here we're going to have negative times this, going to be negative 2ae to the power of negative 2x. So minus, this one is the one that was inside bracket, and then we're multiplying. It's going to be minus 2 ae to the power of negative 2x, and then let's continue. Minus times 2ax times negative 2ex. So here it is going to be positive 4e. 2 times negative 2 is going to be a negative 4ax e to the power of negative 2x here. And so negative times negative is going to be positive 4ax e to the power of negative 2x. Okay, so here it's going to be plus 4ax e to the power of negative 2x. Okay, so this is how it's going to look like. And then therefore we have the same here. We have negative 2ae and negative 2ae. Therefore we're going to have negative 2 minus 2 is going to be minus 4ae to the power of minus 2x. And then plus 4ax e to the power of negative 2x. And so this is our y prime prime, and then our y prime it's ae to the power of negative 2x minus 2ax times e to the power of minus 2x. And then from getting the y prime prime and y prime, we're going to rewrite our equation. The original one. So it's y prime prime plus 2y prime equals to e to the power of negative 2x. So wherever there's y prime prime, we're gonna put the ypi, and then wherever there is y prime, we're gonna put the first y prime pi. So the y prime prime, we're gonna put this one, so it's gonna be negative 4ae to the power of negative 2x plus 4ax e to the power of negative 2x plus 2 into y prime. So our y prime is what? It's ae to the power of negative 2x minus 2ax e to the power of negative 2x. So it's a oh my goodness, I forgot. It's 2 into a. Let me see. 2 into ae negative 2x and minus 2ax e to the power of minus 2x, all equals to e to the power of negative 2x. This is from what? The original function. This is from original function. So now we're going to simplify. So we have a negative 4ae to the power of negative 2x plus 4axe to the power of negative 2x plus 2 times this is going to be 2a e to the power of negative 2x. 2 times this is going to be a negative 4ax e to the power of negative 2x equals to e to the power of negative 2x. And then from here you can see we have 4ax, we also have a negative 4x, so which means this one and this one is gonna cancel. 4 minus 4 is 0, and then we'll be left with what? With a negative 4a e to the power of negative 2x plus 2ae to the power of minus 2x. So it's the same, ae and we have ae. So minus 4 plus 2. Minus 4 plus 2 is negative 2. So therefore, let me open the next page. Therefore, we're going to be left with negative 2ae to the power of negative 2x, or equals to what? To e to the power of 2x. And from here, we can solve for a. Our a is going to be equals to e to the power of negative 2x over negative 2 times e to the power of negative 2x, and then this and this cancel, and then a is going to be 1 over 2, a negative 1 over 2. Our a is negative 1 over 2. And then we're going back to our ypi. Remember our ypi is ax. It's this one, ax times e to the power of negative 2. So we're gonna write the value of we're gonna write our ypi. Our ypi, it was axe to the power of negative 2x, and now we solve for a. Therefore we're gonna write our ypi like this. Ypi equals to a negative 1 over 2x e to the power of negative 2x. Okay, and then we are not done. What we're going to do after here, we're going to add YCF and YPI. Okay, our YPI is negative 1 over 2x e to the power of negative 2x, and our YCF, where's YCF? Our YCF is C1 plus C2 e to the power of negative 2x. Okay, so therefore it's gonna be C1 plus C2 e to the power of negative 2x plus our YPI, which is a negative half x e to the power of negative 2x into negative 1 over 2x e to the power of negative 2x. So this is how we determine undetermined coefficient. And this is how we determine the solution of undetermined coefficient. Officer. Zolapha John, Zolapha esa.
Check. Actually, upload a video and check out food.
Okay. Not title. So we did number C. I'm also gonna send you the solution for other points A, B, C, D, E, F, G, H, and then I'm gonna resolve this one. And so let me just continue and do mechanical vibration. Just a quick one. I'm just gonna show you the equations and then show you how to draw a graph. Annie.
Okay. Kumla ubona final answer. Yeah, good job.
Okay. So let's do mechanical vibration just for 30 minutes. Here I'm just gonna show you the formulas and then how to draw a graph, because everything is the same as what we were doing on activity 3.4 number C. Mechanical vibration. So here we're going to have a simple harmonic motion or free undamped motion. So this is the equation that we're going to use. Okay, before that, we're going to have a differential equation, a transient state and steady state, and then we also have to know how to sketch a graph. So here the main objective here is to know the differential equation, how to differentiate. And then the second one, we're also gonna learn the transient state and steady state. And then the third one, gonna learn how to sketch one circle, sketching one circle. Okay, and then number 4, also gonna learn how to determine frequency, period, and phase angle. Frequency, period, and phase angle. So you're gonna learn how to do this, to differentiate equation, to get the steady state, to sketch one circle, and also to determine frequency, period, and phase angle. Okay, so here let's say actually we're going to have a simple harmonic motion or undamped motion. Let's say we have a diagram like this. Okay, a body, it has a spring and a mass. This is a mass and then this is a spring K, and for sure you know this from physics. Yeah, so this is
theory.
Yeah, theory of machines. Yeah, and then this is spring. Let's say this is our body, and then in this body we're going to have undamped motion, undamped, damped motion, and forced damped motion. And so we're gonna start by undamped motion. So we're going to have undamped. We're also gonna do this in vibration, second semester. But this is mathematics. Number 3, we're also gonna have the forced damped motion. So the first one is undamped motion, and the second one is damped motion, and the third one is gonna be forced damped motion. These are free undamped motion. Free damped undamped motion. Okay, so the equation for undamped motion, and the equation of this is gonna be m d squared x over dt squared plus kx equals to 0. So this one is for undamped motion. So from our diagram, you see we have the spring and the mass. So this is the equation. M is for mass, and then k is for spring, and then this is acceleration. This is acceleration, and then x is what is displacement. And so we have the mass, we have the acceleration, we have the spring, and what, and displacement. And also we can write our equation like this: mx prime prime plus kx equals to 0. So this, it shows that it's what, it's a second derivative. It's the same thing, the x prime prime and d squared x over... Oh, okay. So I was saying md squared x over dt squared plus kx is equals to 0. We can also write it as mx prime prime plus kx. And so the x prime prime, it shows that it's what? It's a second derivative. It's a second derivative. And then from this equation, mx prime prime plus kx equals to 0, we can also get an angular velocity. So angular velocity is equals to what? To square root of k over m. This is angular velocity. And then moving forward, we're also gonna have auxiliary equation. We're also going to have auxiliary equation. So the auxiliary equation is going to be m squared plus omega squared equals to 0. Okay. And then here, this auxiliary equation is going to help us to find displacement equation. It's going to help us to find what? Displacement equation. Okay. So we have m squared plus omega squared. What we're going to look for here, we're going to look for m squared. So it's going to be m squared equals to a negative omega squared. And then to get m, it's going to be m equals to plus or minus square root of negative square, omega square. And remember, we said if we have a square root answer, it's a what? It's a complex. It's a complex conjugate. Remember when we were looking for complementary function, we said if we have a negative square root answer, it's what? It's a complex conjugate or complex root. If we have a complex root, to get a displacement, it's going to be fx of t equals to e to the power of alpha x into c1 cos beta x, beta t, because now we're using what? Mechanical vibration. So it's going to be time versus displacement, time versus acceleration. So t is time plus c2 sine beta t. And so this is the formula for what? For displacement. We call this displacement. Okay. And then here, remember here, we don't have any value. So we can write here that we have 0. We have 0. We don't have any value. And then here it's a square root of negative omega squared. So we can write this answer like this: m equals to 0 plus or minus square root of negative omega squared, like this, square root of negative omega squared. And then here on the alpha, we write the first answer, the first value. So we can write our answer like this: e to the power of 0x. All the time here, sometimes you'll find 1 plus or minus square root of -3. So the alpha is the first value. So the alpha here is going to be 0 into C1 cos beta. Beta, it is going to be the coefficient of, if we have a negative square root like this, we can write it like 1 plus or minus square root of 3j, and the j represent the negative. It's imaginary. So here it can be 0 plus or minus square root of omega squared j. Okay, and then our beta, it is going to be square root of omega square t all the time. So the first value is for alpha, and then the coefficient of j is gonna be beta. Ane? Yeah, plus C2 sine the square root of omega square t. Okay, like this. Here it's sine. Okay, so this is a displacement. When we are going to look for displacement, we're going to use this formula. Or we can write it like this. X of t is equals to a sine omega t plus phi. This is for angle. This is the angle. Okay, and then a is amplitude. Here I'm just giving you the formulas that we're going to use. A is amplitude. Okay, and then to calculate a is gonna be a equals to square root of, we come to our displacement. We're gonna take the value of C1 and C2. Okay, so to calculate displacement is gonna be square root of what? Of C1 squared plus C2 squared. From what? From our equation, from displacement equation. Okay, we get displacement from what? From the values of m. Okay, sharp. So this is how we're gonna calculate amplitude.
Your formula yonenda kuibona ti ya e to the power of 0x ne a to c1 cos. So arali washumisa iranganta iyo wairicha
ipiyo uko bona ka textbook uko ipiyo a arali washumisa a
hapo arali washumisa yongolo fi xt is equal to e to the power of alpha x into c1 cos beta t plus c2 sin beta t. Arali ndashumisa yone formula ringapasi yayo ndisayishumise
hapa noni we were just substituting the values of m. This is the answer. Yeah, we were just substituting. So the first value is gonna go to alpha, and then the coefficient of j is then for the, it shows that it's a negative answer. So the coefficient of j is gonna be at beta. Yeah, here we were just substituting.
Okay.
Yeah, sorry I didn't explain that. Okay, moving forward, this is how we're gonna calculate amplitude. It's gonna be the coefficient of C1 of cos beta t and coefficient of sine beta t. So it's gonna be square root of c squared plus c1 squared plus c2 squared. And also we're gonna learn how to calculate the angle phase. So to calculate angle phase, we're gonna use tan psi it's equals to C1 over C2. So C1 over C2 is from displacement formula. It's from displacement equation. Okay, and then after here we were also gonna learn how to calculate frequency. So this is the formula for frequency, omega over 2 pi, and then for period it's 2 pi over omega. And then remember we were doing we started by undamped equation. Undamped equation it's this one, and mx prime plus kx. So now moving forward, I'm gonna show you the damped motion equation. Okay, so damped equation is gonna be a d squared x over dt squared plus b x plus b dx over dt plus kx is equals to 0. Okay, so here we're gonna use a quadratic quadratic formula to solve for m. So here let's say we have a constant. We have a constant, so which means it's gonna be a constant m squared plus a constant m plus k equals to 0. So this is how our equation is gonna look like. And then to solve for m, we're gonna use a quadratic formula. So it's gonna be minus b plus or minus square root of b squared minus 2ac over this is 4 over 2a. So here on the damped motion, to solve for m, we're gonna use quadratic formula, and then we're gonna get complex rows. We're gonna get m, and then the displacement still gonna be the same. As what? As undamped motion. Still gonna be e to the power of alpha x c1 cos beta t plus c2 sin beta t. Actually, it's going to depend on the values of m. If the m1 is equals to m2, or m1 it's not equals to m2, or m1 and m2 are complex. So here you're going to check, or okay, you're going to get m1 and m2 as a complex, or m1 is equals to m2, and then you write your complementary function. Okay, it's going to be your displacement. And then remember, I also talked about the forced damped motion. And a forced damped motion. So this is the equation of forced damped motion. So it's going to be m d squared x over dt squared plus beta dx over dt plus kx equals to f of x. So this is a forced damped motion, and then the m, it's mass, and then this is acceleration, and then beta is gonna be a restoring force for beta, and then k, it's a spring, and then f of x, it's what? It's external force. It's f of x. Okay, and then from here we can write our function our equation like this, as m x prime prime plus beta x plus kx equals to f of x. To show that it's what is a second derivative, here it's what is a first derivative. Okay, so at the end of this whole thing, we are going to look for displacement. We're still gonna do the same thing to get the YCF and YPA, but this side we're gonna use the X. So at the end we're gonna be looking for YCF plus YPI. We're still gonna do same thing that we started that side when we say we want the YCF and YPI, and then to get YPI we check if it's linear, if it's quadratic, if it's exponential, if it's trigonometric. And then if it's YCF, we check our M1 is equals to M2, and then we write the YCF. And then if our M2 is not equals to M2, we write our YCF. But here we're gonna be using the X for displacement. Remember, here it's what? It's a mechanical mechanical vibration. It's a mechanical vibration. I don't know if you want me to do an example. So should I do example under mechanical, or we'll continue tomorrow?
I think we can continue tomorrow.
Okay, I'll not ties.